Good morning, good afternoon, or good evening, whichever is applicable to you, and thank you for joining us for today's webinar titled When You Need It Now, Getting Information Quickly with REXX. Mainframe analysts and administrators have access to a wealth of tools, report generators, ISV utilities, ISPF panels, and more. However, existing tools may be hard to use, requiring specific expertise, or may not provide adequate detail. And requests for information from management almost always come with the requirement that there's no time to waste. REXX execs provide a simple yet powerful means of processing large volumes of data and distilling it into useful information. Today, we'll take a look at the REXX facilities for accessing dataset or system-level data and how to quickly write REXX execs that can solve problems for both systems and application programmers. This presentation is sponsored by Precisely Software. Precisely is a recognized global leader in enterprise data integrity products for mainframe, mid-range, and distributed systems. For more information on Precisely, please visit precisely.com. Our speaker today is Principal Technology Architect Steve Pryor. Steve has more than 30 years' experience in storage management, design, and support, and speaks frequently at industry events. Prior to joining Precisely, Steve made important contributions at several mainframe software vendors, designing and implementing major products and components. At the end of the presentation, we will have a short Q&A session. Attendee microphones are muted for the presentation, but you may ask a question or request webinar assistance at any time through the Q&A interface. After the webinar, all registrants will receive a link to the slide deck and recording. Thank you again for joining us today. Welcome to the stage, Steve.
Thanks, Ray. Please let me know if the slides don't advance. I will try and advance these. What I want to talk about today is REXX and how we can use some of the facilities that are built into REXX to access data. And there's all kinds of different facilities that are built into REXX. It's a language that's been around for a long time. It's remarkably useful in terms of the range of things it can access and the ease with which it can process them. So I want to talk first of all about where we can get information from. We can get information from lots of different places, from the catalog, of course. There's lots of, the catalog is the keys to ZOS in terms of every data set has a catalog entry that tells us all kinds of information about the data set, where it lives, what volume it's on, if it's a GDG, how many generations there are. There's the tape management system, which has, of course, lots and lots of information about on both the data set level and the volume level about tapes. We can get information from the console. We can actually issue console commands and get information back. So if I want to issue a display command or a modify command to get information from, say, HSM and find out what's active and what's not active, I can do that via the console. I can get information directly from storage. I can look at MVS control blocks. I'm a little dating myself by saying MVS, but I can look at ZOS control blocks. I can get information from the Unix system services, from DB2, or if for some reason I can't get it from any of those places, I have to run some utility. Those utilities will create output files. And the first one, of course, that comes to mind is simply listcat. IDCAM's listcat, you can create an output file and REXX can read that and reformat it pretty easily. So there's lots of different ways that we can get information into REXX. And once it's into REXX, we can deal with it in lots of interesting ways as well. Let me just advance to the next slide, I hope. No, let's see. Enter. No, I'm going to make it smaller and then redo it. Here. Okay, so hopefully the slide now says REXX language strengths. There's lots of the thing about REXX is it came originally, of course, from VM, but it's really sort of built around the mainframe. It's built around ZOS, and it's built around parsing and string manipulation. The REXX parse statement is one that will allow you to break down almost any sort of input really easily, whether it's a fixed record length format, whether it's a bunch of comma delimited or blank delimited words. There's all kinds of parse facilities that you can do with a single statement in a loop, if you like, to parse the input. And so the way you can, this parsing facility allows us to take almost any kind of input, whether it's a control block in storage, whether it's a file, no matter what that input looks like. Parse is really easy to use. And once you've parsed it, REXX is built around string manipulation. Unlike something like COBOL or assembler or some other language where you're dealing with record types perhaps and defining records and so on, REXX is really built around character string manipulation. And so particularly when you're writing some sort of report or you want to you want things to you want to extract substrings and scan for things. REXX has a lot of string manipulation facilities that, again, are really easy to use. There's not a, unlike something like Python, which of course can do all kinds of things, the number of statements that you have in REXX, the parse statement, the various substring functions, there are many REXX functions, but there aren't a million of them like you might find in something like Python. And so REXX is relatively self-contained and easy to use. It's really good at formatting output. The say statement, if you really just want a quick and dirty way of putting something out, the say statement will write to the output, and it's dirt simple to use. There's a certain amount of array processing you can do within REXX. There are what REXX refers to as stem variables. They're basically a one-dimensional array, and if you do a little manipulation, you can make them multi-dimensional. But for the most part, if you just need a table or you have the same thing recurring multiple times, REXX is pretty good at handling that, again, via string manipulation of these array variables. And so, as we said, REXX is it's easy to use because it's mostly an interpreted language. There are REXX compilers. In fact, I think the REXX compiler comes as part of ZOS now, and so you can compile it. But for the most part, people will depend upon it for interpreted REXX, and it's particularly useful and particularly compatible with ISPF panels. If you want to create a really quick ISPF application, REXX is the way to go, because REXX will allow you to get information from any one of those sources we mentioned. And what I really want to do is talk about all of those sources. Get information from any of those sources, and you can very easily invoke functions in REXX. You invoke ISPF functions in REXX to display panels and to process ISPF tables. While all of this graphical interface stuff is great, ISPF is still the backbone of ZOS, and REXX makes it really easy to use. The other advantage of the REXX language is, of course, it doesn't cost anything. You already have it. It's available with ZOS, so it's available everywhere, and it doesn't cost anything to use. So if you really want to use something quickly that's capable of getting to almost any piece of data you might want and formatting that piece of data in the way you might want, REXX is really the way to go. And so let's talk about, I want to talk about a number of the different REXX functions. I won't talk too much about the REXX language itself. I'll give some examples here of how you might do it. But I want to talk about the REXX functions that return data to the REXX exec. There's lots of them. There's dozens of them, really, at least a dozen, maybe 2 dozen. The simplest one, if you're just looking for dataset information, is just list DSI, list dataset information. And many of these functions, list DSI particularly, are actually TSO functions. This is what REXX refers to as a TSO external function. So it can only be run in a TSO environment, which means if you want to run it in batch, then you have to execute program IKJEFT01, which is not normally a problem. If you just want to get some information, I can run a batch TMP, a batch IKJ EFT01, to get the information I want. And so it's a REXX function, and REXX works much of REXX works on functions. You specify the function name and the function parameters, and you call it just by setting some variable to the function name. In this case, X is list, and we invoke the list DSI function for a given data set. You need the quotes there unless you're running under TSO and you've set no prefix. And the information for list DSI, so simply this one statement, list DSI and my dataset name, or it could be a DD name. And there's a bunch of other parameters I could specify depending on what I want to get back. But I can get back 35 or 40 different variables with a single statement. So I can say list DSI, my dataset, and then all of these variables are named, and so I have a little snippet here that shows you the sorts of information we get back, and they're all named sys something. So naturally, sys DS name, sys volume, unit, dataset organization, rec form, key length, number, if it's PDSE, used pages, the primary space, the secondary space. There's all kinds of information. All of this comes from either the catalog or the volume, and so with a single statement, I can get all of this information back to list DSI, and I can sort of limit the amount of data information I get back. I can say I don't want to go against the catalog, I want to go against a particular volume, but do I want directory? So I can pass parameters for, do I want directory information? Do I want information for just the first volume, or do I want it for multiple volumes? Do I want RECF information? Do I want to recall the data set if necessary? It might be migrated by HSM or FDR. Do I want the SMS information? Do I want the class name, the data class, dimension class, storage class name? All of these variables are, of course, the information you get back is documented, but they all have, there's a whole bunch of variables you can use. So if I want information on more than one of these, I can simply put this in a loop. List DSI, of course, will return information on a single data set at a time, whatever data set you give it. So list DSI is a simple way of getting a bunch of information. sysdsn, well, there are some limitations before I get to that. List DSI, there are some limitations. And this is generally true of REXX. It's not terribly good at getting information back for VSAM datasets. For ordinary garden variety sequential datasets and partition datasets, it's very good. It'll return all of that information. For VSAM datasets, it will give you only the dataset name, that is the component names, the vol seer, the unit, and the DSORG, whether it's a record for the type of VSAM dataset, whether it's key sequence or entry sequence, and you get a return code 4 just to warn you that I'm not giving you all kinds of information back. There are some other limitations to list DSI. It doesn't work for relative generations, and you want to be careful about coding saying I want too much information, because I don't want to necessarily recall 1,000 datasets to do this. And if I say directory, I have to open the data set to look at how many directory entries there are. And directory might actually update the last reference date since I have to open the directory. sysdsn, I might want to issue a sysdsn before I even issue list DSI to say, does the data set exist or not? And it's really, so this is again useful if I'm particularly in a loop. Does this data set exist or not? And here's a little REXX snippet where I'm saying, given an input data set name, argument DS name, then the function code, or FC, or I can use any variable name I want here, but is sysdsn and the data set name. And then the value returned is either OK, which is the data set exists, or something else. And in this case, we use the REXX message facility, because this is, again, list DSI and sysdsn are both TSO functions. So this is running under TSO. And so I want to, before I issue a sysdsn, and maybe before I issue list DSI as well, I want to suppress the messages from TSO. And there's a REXX function to do that. I could say message off to suppress the TSO messages, and then the message again and you would think it would be on, but it's the value that I used for message off in message to restore the TSO messages. So if I just want some basic information on a data set, particularly on a sequential data set, sysdsn will tell me whether that data set exists. listdsi will tell me, well, pretty much everything I might want to know about the data set. The other place, of course, one other place that we can get lots of information about data sets is from the catalog. The catalog is integral to ZOS, and so there's we could, of course, always just run a listcat, but maybe we want information that listcat isn't going to return. Or maybe we want information about a whole bunch of different data sets and we don't want all of the listcat information. We just want a certain piece of the listcat information. Maybe I just want the primary space or secondary space or the encryption key label or something like that. So I can invoke the catalog search interface, which is an interface to SVC26, which is the catalog SVC. And IBM for many years resisted putting out documentation for SVC26, and lots of the vendors like ourselves use internal calls to SVC26 to get our information. But IBM finally documented and made legal calls to the catalog to get fields back from the catalog to find out what's the high allocated RBA, what's the high used RBA, whatever catalog field you might want to think of. So you can call the catalog search interface from the assembler, from HLASM, or from any other high-level language, or you can call it from REXX. And the interface is program IGG-CSI00. That's actually the interface that calls SVC26. And really all you need to do is call IGG-CSI00 with certain parameters. And we can do it within REXX by calling, by using the link PGM environment. So there's a REXX statement, address link PGM, and then the program you want to link to, which in our case for the catalog search interface is IGG-CSI00, and the parameters to that program. So the inputs to the catalog search interface are the dataset name that you want, what in SVC26 is referred to as the generic filter key. It's really just the dataset name mask. And the particular catalog entry types that you want. Is it a VSAM dataset, a non-VSAM dataset? Do I want cluster information, and so on? And there's some other parameters you have to pass. Normally, one you would often do this in assembler, in HLASM, but it can easily be done in REXX. The trick is to know what catalog field names you're looking for. That is, what information do I want from the catalog, and how is it formatted? And now this allows me to look at more than one dataset name at a time because I can specify a mask. And so I may get a whole bunch of information returned, and therefore I may have to call IGG-CSI00 in a loop. There is a resume flag that gets set that says, if you didn't provide me a large enough work area, I will let you know, and then you can re-invoke me with the resume flag set so that I will give you the next chunk of information. And we can get almost anything we want out of the catalog search interface. But in order to do it, we have to pass an assembler style parameter list where register 1 points to three addresses. One is the return code and reason code. The other is a bunch of catalog flags and fields that we want, the catalog name, the resource name, and so on. And register 3 and address 3 points to work area. And that work area is where the data is returned. So REXX, we will with REXX parse the return data in the work area. So we can invoke IGG-CSI00 with REXX. We'll have to set up this parameter list, and I have an example, I think, in the next slide. But the work area is where the data is returned. And so it's a piece of storage. And there are entries for each field that we asked for. And so we asked for a number of fields. I'd like the dataset name. I'd like the primary space. I'd like the DSORG, I'd like the LRECL, all of these sorts of things that might be stored in the catalog. Well, DSORG and LRECL are stored in the DSCP, but things that might be stored in the catalog, the volume serial list, as I said, the encryption key labels, things like that. And so there's one entry, there's an entry for the field information for field 1, and an entry for the returned information for field 2, and so on, however many catalog fields we want to ask for. So the trick is to know which fields to ask for. And this is documented in the IDCAMS manual, in the Access Method Services Guide. There's lots and lots of catalog field names, and they're kind of esoteric because they're limited to 8 bytes. And I can ask for things like the vol ser, the key label, the 8-byte high allocated RBA address, the number of extents, the compression indicator, is the dataset compressed or not compressed, what's for a VSAM key sequence dataset, what's the key location and position, for tape datasets, what's the console ID and the library ID and so on. Or for this particular volume, what's the creation date of this tape volume? So any information that for any data set or volume that I want to get from the catalog, if I merely specify the correct catalog field name, I can get it back. And so an example is, of course, worth 1,000 words, and the place to look for an example of this is in Sys1 SAMPLIBE. There is an already coded for you REXX example called IGGCSI REXX, which uses REXX to return information from the catalog using these field names. There's an actually even better example at ftp.software.ibm.com, and you can actually log on to that system. It's open to the public, although you do have to use secure FTP to log onto it, but you can log onto it with an anonymous user ID. And if you navigate to servers, storage, support, software, DFSMS, cat tools, eventually, and then down one more level to II41316, there is a REXX exec and the JCL to run the REXX exec to do this catalog search interface for any arbitrary field you might want, or set of fields you might want, and any arbitrary dataset name. So the catalog, you can get information via REXX from the catalog for just about any field you want in the catalog, and IBM supplies you some examples of how to do that. So we'll talk about a couple more REXX functions, because there are, as we said, a couple of dozen of these, and we'll try and talk about the more interesting ones. Sometimes you don't want dataset information, but you might want system information, system level information. And this is particularly true if you're at an ISV or you're doing system programming of some type. You might want information about the ZOS system itself. And so there's two REXX functions, both of which are TSO, again, TSO functions, so they have to run under TSO or batch TMP. There's MVS var, which will return you the information for a specified field. So the DFP level, the MVS level, the system name, whatever your 4-character system name is, the operating system level, security labels. What's the sysplex name? What are your system symbols? We can get that back for any individual variable by saying, I'd like the information returned in this variable, and this is my argument. My argument is either the character string, sysdfp, sysmvs, sysname, and so on. Sysvar will tell me about, actually it will return a whole bunch of information. Well, it'll return, again, like MVS, MVS var, it'll return one thing at a time. And so if you want to know about the execution of a particular REXX exec that is running, or you want to know something about system information, you can use sysvar. and it works the same way, variable equals sysvar, open paren argument. And the way this is done for, if you want to do it for a whole bunch of things, I have a sort of a snippet here that says, I'm going to use the REXX stack. And if you get into using REXX in detail, the REXX stack is a really useful tool to stick things in and then pull them out one at a time. So we queue the variables that we're interested in and the description. We queue sys CPU, sys HSM, sys JES. I'd like information about the CPU time used, the HSM level, the JES level. And so I then put it in a loop. I say do while queued, which says as long as there's anything in the stack, I'm going to pull this argument out and run it through sysvar. And so this will allow me to get a whole bunch of information out and display it with a matter of 5 or 10 lines about the things like how much CPU time's been used by this REXX exec, what's the HSM level that we're running on the system, what's the RACF level, or any of these other MVS variables. So again, really easy to use, and again, because of the string manipulation and variables within REXX make that really easy to use. More system information, we can use sys CPUs and sys storage. Allows us to get information about the CPU ID or from any get information about any location in storage. And so if we want to get information about the CPU ID, well, we could go to the console and do a display m, CPU. But if we want that information back programmatically, or if we want information back programmatically about some particular location in storage, and of course, COS is all about control blocks. It's all about control blocks that pointers in storage that point to other pointers in storage. And so there's two RACF functions that are of interest there. One is sys CPUs, which will return you the CPU ID and model that you're running on. And that's very often used by vendors to find out what CPU you're running on. More useful probably is the storage operand, the storage function, which will obtain data, or you can actually write data into storage at the specified address and length, which allows us to get to data in ZOS control blocks. Things like the CVT, the common vector table, is the key to all of the ZOS control blocks, and it contains pointers to many other control blocks. And so if I want to get information from the CVT, things like the MVS version, or maybe I want to look at the RACF control blocks, or I want to look at any number of other control blocks, I have to use several REXX functions, because REXX again is a string-oriented language. So there are 3 REXX functions that I might use to manipulate the addresses: character to hex, C2X, decimal to hex, D2X, and then X2D hexadecimal. And so it's just, again, just like the REXX, any other REXX function. This is not a TSO only function. This will work for in a non-TSO environment, I believe. We can simply say storage, address, and then the length. I think the default is 4. Well, I'm not sure if there's a default. And then if I want to put data into it, I can actually put the data into it there. So if I want to get the address of the CVT, well, the CVT is always at location hexadecimal 10. So I can say CVT is convert to decimal, storage, location 10 for 4 bytes. And then the CVT address is take that and convert it to hexadecimal. And then I can write the CVT address. And more importantly, now that I've got the CVT address, I can go to the CVT prefix, CVT -40, and I can get the MVS version information from the CVT prefix. And I can say MVS version is, and of course, there's many other things that are in the CVT that one can get to. And so the storage function within REXX allows us to get to any piece of addressable storage. To just give you another example here, oops. Storage, we can use, we can invoke some program, or we can invoke some system function, We can call a program via link PGM. And if that program returns information into storage, we can use the storage function to obtain that information and then convert it to something printable and display it. So to take an example, IWM QVS, Query Virtual Server, is a program. So it has to be invoked, if you're going to invoke it in REXX, it has to be invoked via link PGM. And Query Virtual Server will allow us to obtain the system capacity information for a particular system. What's the KEK ID? What model ID is it? And so on. So if you want to invoke IWM QVS, we can say address link program IWM QVS, and it will return all kinds of interesting information, the LPAR name, and so on. But it returns it into storage because we've invoked this program, and this is a program designed to be called from another program. So it returns its information into storage, but we can use the storage function in REXX to obtain that information. And so there's some examples actually, if you have our SyncSource storage management products, ACC, SRS, SMS Debug, Easy Exit, we have an example of that in the SampleLab library called REXX QVS that will return you information in this way using IWM QVS and the storage macro. There's some other very similar REXX execs available on the web. There's one, Mark Zeldin has lots of MVS utilities, and so there's an example there. Or if you're not familiar with it, you should look into the CBT tape, which many years ago was called the Connecticut Bank and Trust tape, because that's where it was originally developed, and it was originally a tape. But now it's just a whole list of MVS open source freeware, much of which is REXX, and there are lots and lots of good examples there at cbttape.org. Okay, other places we can get information in REXX that you might not think about is something like the tape management system. RMM has a TSO command that will return information for data sets, for volumes, for RMM settings, for remote locations, all kinds of things that you might want from the tape management system. And so you can issue a TSO command to get that information back, and it'll come back to your TSO session. But if we want it in REXX, we can use the address TSO environment, and we can issue that TSO command, which might be list volume, search volume, list data set, and get that information back in REXX variables. So if I want to query the tape management system and say, show me all the volumes with a particular expiration date or that are going to expire before some date, I can invoke the REXX API. I can use the REXX API, and I just create my TSO RMM command, which might be, again, list volume, list data set, search volume. And as long as in my REXX exec, I set a variable called sysoff.eggdate, which basically says this is the way I want to return the date format. But as long as that variable is set, instead of in RMM returning that information in TSO variables or into TSO and printing it out, it will return all that information in a bunch of REXX variables. And they all begin with EDG @ EDG being the prefix for RMM. And so I can get information about any volume, any data set, any library, any system volume, any set of volumes, and I can get all of that information returned in REXX variables. And those variables are all predefined. They're defined in the REXX or in the RMM manuals, to say EDG @ date, EDG @ Volsier, all of the information I might want to get from the tape management system. You know, which volumes are scratch, which volumes are non-scratch, which are about to expire. All that sort of information is available from RMM. And so we have an example here of getting the RMM Volsier data information. And so I set my sysoff.edg date to the character string normal, which tells RMM that I want this information returned in REXX variables. And then I issue my RMM command, which is address TSO, RMM list volume, LV, and the vol here I want. And then I check for return codes and so on, but now I can simply reference any of these EDG @ volumes. Because I issued RMM list volume and gave it a vol here, I can look for the vol here name at EDG @ volume. I can look at the expiration date for that volume at EDG @ XDT. I can look at the creation date at EDG @ CDT and so on. The assignment date. So I can do this for any piece of RMM information I want, whether it's at the dataset level or the volume level or the RMM level. And again, really easy to get to programmatically get information that otherwise you might have to write an assembler program for or post-process some report output or something like that. But speaking of post-processing some report output, a lot of times you can only get information from a file. And so the REXX exec.io statement allows you to read from a file. And as we said, REXX is really good at parsing things. And so the thing that you typically think of parsing is something like IDCAM's output. Either the listcat statement, which you can use listcat to get all of the information you want from the catalog, and then just because the listcat format is fixed, it's really easy to parse with REXX. Similarly, decollect, in which I have an example here, the IDCAM's decollect command will go out and give you all kinds of information about your DASD system, both on the volume level and the dataset level. Will give you information about what's migrated, what's not migrated, give you HSM information. But it comes back in a fixed format record. Well, REXX is really good at dealing with fixed format records. So in this case, if I've invoked decollect, IDCAM's decollect, I can parse that information by specifying what column each field is in. So the record type, the version ID, the free space on the volume. This is a volume record. The free space on the volume, the capacity of the volume, the disk volume, the fragmentation index, all of that is easily accessible with a REXX parse statement. So similarly, I can do this for any sequential file. So I've done it in the past where I take the TMS or TLMS database, dump that out to a file. That's a fixed format, and it's very easily processable with REXX. I just use exec.io diskr to read from the disk. And you can either, typically you read for a certain number of lines and put this in a loop. If it's not too large, you can say exec.io star, which says read me the entire file into storage. But typically you put it in a loop for some number of lines. So if we have, this is done for all kinds of input. And so if we don't have a direct interface to the information we want, we can simply get the information out of the file. Some other locations where we can get some information, the console. We can issue console commands. You have to have authority, of course, to issue the TSO console activate command. But once you've issued that TSO console activate command, you can specify address console in REXX, and then whatever command you want to issue to the console, which in this case is modify DFSMS HSM query setsys. And it will return to me all of the, return to me the query setsys output. Now I have to parse that myself. And so I can use get message to retrieve that message. So the result is get message, and I put it into a stem variable called RESP dot. And then I just, the stem variable, I can process that stem variable, which will give me each line of the response. And there's an example of this in hsm.sample.tool. In sys1 sample lib, you run arc tools, and that will create hsm.sample.tool. There's a member called query set that will give you an example of doing exactly this, getting information back from the console, in this case for an HSM command, but of course you could do it for any sort of console command. Other places you might not think of to get information. SDSF is really good at returning information into REXX. You can enable the SDSF environment by specifying address SDSF and then ISF exec, and then the particular SDSF panel you want to run. And so it'll actually execute SDSF panels, and it will create stem variables for each row and column in the panel. So if I wanted to do it, for example, for the status panel, I'd say address SDSF, ISF exec, ST or status, that invokes the status panel, and then I can process each row with the token parameter. And so there's when I could actually take action if I wanted to. I could say ISF act, and if I wanted to purge a job, there's lots of information I can get back from SDSF. And so I have an example here where we enable the SDSF environment. You actually got to say ISF calls on, and then I'm reading a list of unit addresses for which I want to do a vary online. And the vary online is simply, I set the command name, vary unit address online, and then I can invoke SDSF, ISF exec, to issue that command and wait for the result. So we can do all kinds, and SDSF, of course, has many, many different functions. So there's lots of things that you can do in REXX with SDSF to automate SDSF processing or automate any sort of system processing that SDSF could do. Similarly, you can get REXX, as we said, has lots of ways to get into it. We can get information from Unix system services, the syscall command in REXX, or the address syscall environment, allows us to invoke USS commands. And of course, this will run in TSO and USS shell, whatever environment you want. It'll return you the return codes. And there's lots and lots of Unix system services, callable services. So in this case, to give you an example, I could say address syscall, which is the environment for Unix calls. And if for a given set or I want to list all the ZOS users and directories, I can say issue the get pwent Unix system services command, and he'll go ahead and get the database entry, and then I can just use a say statement to get the to write the user ID and directory out that I get returned from the syscall get pwent. So I can get information, any information I want, again via REXX from Unix system services without knowing all kinds of without having to write a complex assembler program. Same thing is true with DB2, and I won't go into the gory details of DB2 here, but I can also invoke DB2 functions from REXX using DSN REXX. So you make the DSN REXX environment available by specifying subcommand DSN REXX and the particular subsystem you want. In this case, it's DBCG. And then I can go and create SQL statements and execute those SQL statements and connect and disconnect to DB2 and DB2 subsystems, again, all from REXX, and get the information I want, again, relatively easily and easily parsed. I get the information back and I can parse it. There's lots of other topics that we could cover here. This was really just an overview of the types of information, the types of access that you can use, types of places that you can access things with REXX. As we said, ISPF is REXX and ISPF go together very well. Not only is REXX useful for invoking ISPF functions and displaying ISPF panels and things like that, but there is a whole subsection of REXX called panel REXX, where you can actually run REXX when the panel is displayed. You can run REXX when you're doing file tailoring, ISPF file tailoring. There's something called system REXX, which if you want to run system level stuff. And of course, there are non-ZOS REXXs as well. So just to give you an idea that there's lots of information out there, and it's actually easily accessible. And REXX is a really good tool to do that because its string manipulation capabilities and its parsing capabilities are really good. And where is all this documented? This is sort of the list of resources that I went to produce this. There's the TSO REXX Reference and Users Guide. If you're looking for the catalog search interface, that's in the back of, well, not in the back, it's in chapter 11 of DFS Managing Catalogs. There's actually some examples in a rather old red book that actually provides a really nice description of how VSAM works, VSAM Demystified. And then in RMM, there's the RMM manual, Managing and Using Removable Media, talks all about the TSO subcommands in chapter 12, the REXX variables. SDSF User's Guide will tell you how to get information out of SDSF using REXX, or if you must, you can go to the succeeding chapters to get information out of REXX using Python or Java. And then if you want to get information for Unix system services, of course, there's a manual for that as well. So there's lots of one of the nice things about the IBM environment, of course, is not only is it powerful and easy to use, but it's well documented, and that can't be said about some of the open systems environments. So at this point, we actually have unusually a little bit of time for questions if we have any questions. So I guess I'll stay on stage. Yeah.
All right. Thanks, Steve. At the moment, we don't have any technical. Getting a little bit of feedback from you, though.
Oh, sorry. There we go.
But yeah, general questions. Still getting feedback.
No, I'm muted.
Oh, that's weird. Anyway. General questions. We are recording this session, and everybody will get a link to the recording afterwards. Oh, we did have a technical question just pop up. Is there a GUI debugger?
Well, I think the short answer to that is no. You could probably do it using Zoe. I mean, there's a certain amount of things you can do using Zoe, but REXX is really a procedural language. There might be for non-ZOS REXXs, but I'm not really familiar with that for ZOS REXX. And yeah, as you say, use say statements to debug. Say statements are wonderful because they're really easy to use. There are some signal statements that you can use to signal on some unusual condition that will put you off into a routine if things go wrong. But yeah, say statements tend to be the thing to use. And there is a trace statement. Yeah, trace is actually really useful. The trace command has there's several different flavors of it depending on you want to trace everything that goes on. You want to trace all the variables. You just want to trace the statements. Trace is real easy to turn on and off as well. And so trace is an excellent debugging utility. One of the nice things about REXX, besides its string manipulation and its parsing capabilities, is the trace command and the say command, because it's really easy to debug. Other questions or comments? Okay, well, thanks everyone for attending. I know it's still early in the year, it's April, but if you're looking at going to Share in Pittsburgh, we will of course be there. We'll have a booth, and at the moment I'm planning on being there, and so hopefully I will see some of you there. As Ray said, we'll send out copies of the slides to everyone, and if you have questions, certainly feel free to email me. If you want to email me directly, it's now steve.pryor, Pryor, @precisely.com. And I'll be glad to respond directly to questions if you like, and evangelize for REXX a little bit. So thanks everyone for attending, and Ray, I'll turn it back over to you.
All right, thanks, Steve. We will have the May webinar information coming out soon, so keep an eye on your inbox for that. And again, thanks everybody for attending, and we'll see you at the next one.